We're in Union Station, downtown Los Angeles. We're gonna learn something today. All right, come on around. Today's question is, what is a virus? This is gonna be the start of what I'm hoping is gonna be a good series where I will try to do the best I can as a doctor, as an emergency room doctor, to explain to you what this whole virus fear and scare is all about. So come on, let's draw a picture here. All right? So we're going to start with the inside of the virus, and we're going to work our way out. The inside of viruses, well, first of all, let me just tell you, a virus is a particle. A virus is a particle. We don't know why they exist. We don't know who made them. All we know is that they do exist. A virus is a particle made of organic material. Why am I being so detailed or not so detailed? Is because a virus is not made out of metal. It's not made out of plastic. It's made out of the same building blocks that people and living things are made out of, but a virus is not really alive. It's kind of this particle that's just lingering there, waiting to do something. So before I can talk about what a virus does, let me just try to describe the structure of this particle. So come on up. Okay, we're going to start with the inside. The inside of viruses contains DNA or RNA. DNA is deoxyribonucleic acid. I'm not going to explain that. RNA is ribonucleic acid. And basically, DNA and RNA are the building blocks of all living organisms on Earth. In outer space, I have no idea. Okay, so inside of all viruses is RNA or DNA. Okay? And then what's around that, I'm just going to draw kind of a picture here, is a bunch of little tiny proteins, and each virus has its own different proteins. They're all organized in a different fashion, and this protein coating is referred to as a capsid. So this is the capsid of the virus, or the protein coat, and then outside of this capsid is another layer, and I'm going to try to draw it a little bit of it this way. You'll notice that I'm drawing kind of what looks like two layers. And I'm going to describe to you a little bit about these two layers. It's going to take a minute to do, but I kind of want this to sink into your head while I'm doing this, because one of the keys of what I'm doing for you guys on this channel is to explain something to you in a way so that I only have to explain it to you one time, and that you'll remember this for the rest of your life, okay? So let me just kind of work my way around here. I'm not drawing sperm, by the way. This is... okay. Okay, so this is what's referred to as a phospholipid bilayer. I know this is kind of sciencey, but I'll explain it in a moment. Bilayer. Okay, I hope you get that. So inside, you've got DNA or RNA. You've got the protein capsid. You have a phospholipid bilayer on the outside. This is the structure of some of the viruses that can cause runny nose, congestion, and cough. So this diagram here this is a general diagram of viral particle. This thing is what you're scared of. This is what you're scared of, something that's kind of like this. is causing the infection that's going around the entire world right now. I will tell you one little bonus is that hand sanitizer, the same kind of the alcohol hand sanitizer that you can get, believe it or not, for this particular virus, which we'll talk about soon, hand sanitizer actually kind of like destroys this outer layer right here. And by destroying that outer layer for this particular virus, the hand sanitizer kind of kills the virus. But remember, a virus isn't really alive. It's just kind of like a particle. So there it is. There's your introduction to what is a virus. It's a particle that's not living, that causes bad things. And in the next video, we'll talk about that. All right, I just thought of a couple things I can't explain. So right here, see this phospholipid bilayer? I'm going to explain that because it's kind of a complicated concept. So you have an end that kind of looks like the head of a sperm, but it's not. Try not to laugh. That's the phosphate molecule or atom containing portion of this layer. And then you have the lipid section, which is fat. So I have no way of really giving you phosphorus or phosphate ions. I can't really explain that, but I can tell you that this is fat, just like any other fat that you would normally have. And so how does this relate to something that you can kind of understand? Soap has fat in it. Your skin cells have fat around the cell. So a cell has this layer that looks exactly like this. And for some of the viruses that you get, because they come from people or animals or something, when the virus goes from inside of the host cell, host will be a cat, a dog, a person, and the virus goes out. As the virus goes out, this protein capsid with the DNA or RNA, as it exits the cell, sometimes it takes a little bit of that cell membrane with it. And the cell membrane is made of this stuff. And so some viruses, depending on what cell they're coming out of, they'll take on some qualities of that cell. It's kind of scary because there's a million or billion different kinds of cells out there. This viral capsule, or this viral capsid, as it exits, takes a piece of whatever it was inside. So sometimes it'll go inside one animal and it'll exit the cell and take qualities of that animal. It'll go into another animal or person, the same virus, and it'll take little pieces of the cell membrane of that animal. Or so the inside could be the same, but it's kind of like putting on a different jacket each day. I'm still the same person, but I'm wearing a different jacket, kind of disguised or a little bit different. And that makes this whole world of virology super complicated. But this is just the fundamentals so that I can go further into this whole coronavirus problem and epidemic and pandemic that we're facing right now.